8.3, number 36. Instructions are use integration, direct comparison test, limit comparison test, determine. So we're trying to figure out if this integral converges or diverges. So one approach would be to recognize that, and there's some symmetry from -1 to 1, and 0 is not a part of the domain here, but the natural log of x is an even function, so we could basically double it from 0 to 1. So this area and that area are going to be the same because it's an even function, symmetrical with the y-axis. And so we could say that's the same as 2 integrals from 0 to 1 of natural log absolute value of x, or just natural log of x, because it's positive now. So that kind of takes care of the absolute value also. So antiderivative, so we're supposed to, so that's boundary, the bottom one, you can't do a, so limit as a goes to 0. Antiderivative of natural log x requires integration by parts, so it's u is natural log of x and dv is dx. Du equals 1 over x dx, and v equals x. Remember, integration by parts is u v minus integral of v du. So u v minus integral of v du. So it's x natural log of x minus integral of dx, which is just x. So x natural log of x minus x is our antiderivative. And we're going from a to 1, and we still have our 2 also. So we'll just do the 2 at the end, and limit as a is approaching 0. Okay, so if I drop in my 1, I get 1 times the natural log of 1 minus 1. Natural log of 1 is 0, so 0 minus 1, we get -1, minus a for x, so it's minus a natural log a minus a as a goes to 0. So what happens with, if we're sending a to 0, what does a natural log a become? So that's kind of a sub problem over here. Find the limit as a goes to 0 of a natural log a. Well, we get 0 times basically infinity. Natural log is 0. It's actually negative infinity, but it's indeterminate nonetheless. So we could write it in rational form by putting 1 over a in the bottom, and then if I plug in 0, I get infinity over infinity, which is indeterminate. So we can do L'Hopital's, so it's 1 over a over -1 over a squared. If I multiply the top and bottom by -a squared, I get -a. And a is approaching 0, so we end up getting 0. So all of that gives you 0. And then minus a, which is 0. So -1 minus 0, we get -1. And then we still have that 2. So that's 2 times -1, so we get -2. So the outcome here it's not as important, but just knowing that well, it's not what they're asking. They're asking whether it converges or diverges, and since we get a finite answer, therefore it converges.